Hi, this is Michael Dooley from Dooley Wastewater and Environmental Consulting. I'd like to introduce you today to our sensor OUR system. So this instrument that I'm going to show you today measures dissolved oxygen, mixed liquor suspended solids or turbidity, oxygen uptake rate, specific oxygen uptake rate and temperature. It's deployed today in a river in Scotland. It's part of our Section 82 process today. But aeration consumes about 1% of the generated electricity in the developed world, and this system targets a 40% improvement in that energy consumption. The key part of our system to distinguish it from other systems is that it's auto-cleaning and auto-calibrating. This allows us to get much better control of the aeration system, and also we can implement feed-forward and feedback control strategies. But this particular unit has been deployed in this river system for 16 weeks continuously, so I'm just going to take it out and show you the main components and show you how clean they are. So the core is now extending out of the sample chamber. This is the normal position it will be in when it's monitoring the dissolved oxygen, and what you can see here is a lot of build-up on the non-sensing parts of typical algae level build-up or typical dirt build-up on the system on the plastic parts. But you can see that the dissolved oxygen sensor I'm pointing out to you here is perfectly clean. That's because it's wiped and cleaned every 30 seconds. The black dot is the LDO sensor. And now we'll turn the instrument around and I'll show you the MLSS sensor or the turbidity sensor, which is the green sensing device here. Again, you can see there's a lot of buildup of dirt and extra materials around about the sensor, but the sensor faces themselves are perfectly clean. The example that we just saw from a river water system is actually quite representative of what will happen in an activated sludge plant. So Claire is now demonstrating to you the swap out of the wear and consumable parts on the system, which should be every 6 months. Once again, just to show you in the clean state, the MLSS sensor, the dissolved oxygen sensor, and actually the two devices on the bottom are aeration stones to do our oxygen uptake rate test. So the swap out of the cylinder contains the MLSS calibration blocks and wipers here, and on the other side, the upper side, we can see the dissolved oxygen wiper. The sensor OUR system was originally developed to optimize energy use in the activated sludge aeration process, with the added benefit of reducing greenhouse gas emissions, including nitrous oxide and carbon. Thanks to its advanced auto-cleaning and auto-calibrating design, we are now able to deploy the same technology for the mandatory Section 82 continuous water quality monitoring requirements in England. This is one of the optional features of the system, where we've got off-grid solar generation with a battery backup system providing 7.2 kilowatts of energy. It's exactly the same system that is deployed with different instrumentation to do feed-forward feedback control of the activated sludge process. Similar to an activated sludge install, this installation also has auto-calibrating ammonia pH and conductivity with push data update to the cloud.